So for section 1.6, we're going to be looking at multiplying and dividing by real numbers. The first thing I want to get out of the way is that by multiplying by 0, we call this the zero product property. Okay, and the idea, if I multiply anything by 0, I get 0. And by the same argument, if I multiply 0 by anything, I get 0. Okay, the way that we think about this is initially by, if I multiply 3 times 4, well, you can know, well, that's 12, right? Basically, we're saying add 3 4 times, right? Add 3 3 times, and we would get 9. Add 3 2 times, and we get 6. Add 3 1 times, we get 3. This says add 3 0 times. That means we don't have, right? We don't have anything, and that's why that's a 0 there. Okay, so anything times 0 is 0. 0 times anything is 0. But we have to continue this pattern into negative numbers, and if you don't like that, that's okay. I understand, but you can blame the bankers, because there was years and years and years that mathematics pretty much only dealt with positive numbers. But the banks decided we needed negative numbers. Why might they do that, right? The idea is that they lend you money, and so they want a representation that's negative to show that you owe them. Okay. So we had to start multiplying by negatives. We had to start introducing that into mathematics, and opened up all kinds of different directions we could do things. And that's okay, but don't blame me, blame the bankers. So what's cool with this is we notice as we're going down in this pattern, we keep subtracting 3. Every time I take away 3 times 4, 3 times 3, 3 times 2, I'm taking away a group of 3, right? So by the argument, 3 times negative 1 should be 3 less than 0. Or negative 3. And then 3 times negative 2 would be 3 less than that, or negative 6. We generalize this pattern by saying, look, every time I multiply a positive and a positive, that makes sense. I can count 3 4 times. I can count 3 3 times, 3 2 times. Whenever I multiply a positive with a positive, I get a result that is positive, right? But when I start multiplying that positive by a negative, as I keep taking that away, once I get past 0, that makes that result negative. This relationship goes either way. I can actually, if I do 3 times negative 6, now here's what we're going to do. We're just going to multiply 3 times 6, 18. But you have to remember that when I have one negative, a positive times a negative makes it negative. This is different from the adding that we did in the previous sections. This is not adding. This is multiplying and dividing. Totally different set of rules. So, you know, just like if somebody came in and said, what's 5 plus 5? And somebody yelled out 25. You'd stop and look at them and go, no, that's not the rules for adding. That's the rules of multiplying. They're different. And you need to separate the differences for the ideas of adding, subtracting, multiplying, and dividing. Okay? So for adding, it matters when one sign's negative. We look at it and we go, which one's bigger? Because they cancel each other out. With multiplying, whenever we have one negative, our result will be negative. Now that also works if the negative's at the beginning. This says add negative 3 6 times, right? If I add negative 3 plus negative 3 plus negative 3 plus 6 times, I'm going to end up with negative 18. If I add negative 3 plus negative 3 plus negative 3 plus negative 3 plus negative 3, one more, plus negative 3, then those all combine to make 18 negatives. So whenever there's two positives, we already know, yeah, that's going to be positive, duh, we get that. But whenever we introduce one negative, whether it's at the beginning or at the end, that makes the result negative. We can show that here. Negative 3 4 times means negative 3 times negative 3 times negative 3 4 times, so we're counting it 4 times, would give us a 12 that is negative. So we should already have that. A negative times a positive is the same thing as a positive times a negative, so the result will be negative. That means all of these, where there's only one negative, all of those are going to be results that are negative. And then all you have to do is multiply the numbers. 3 times 3 is 9, 3 times 2 is 6, 3 times 1 is 3. Now this is times 0. What's anything times 0? 0. We've done that already. What happens when I multiply a negative times a negative? Well, let's look at the pattern first. Okay, here's a pattern that I see that as I'm going down here, because I'm going by negatives, instead of subtracting 3, we are adding 3, right? So if negative 3 times 1 is negative 3, negative 3 times 0, add 3 is 0. What's negative 3 times negative 1? Well, add 3. What's negative 3 times negative 2? Well, add 3. So what does this show us, right? We know that a positive and a positive multiplies to make a positive. A positive and a negative is negative. Here we saw a negative and a positive is negative. But now we see that a negative times a negative, when I have two negatives, they multiply to make a result that is positive. Now, if you don't like this argument, there's another way to think about this by thinking of the word opposite. So when I say what is the opposite of 5, I think this is vocabulary we've seen before. That opposite basically means a negative, right? The opposite of 5 on the opposite side of 0 is just negative 5. What's the opposite of a negative? Well, opposite just means we have like a negative in front of it. We basically have a negative 5. And in the past we said, well, we understand that makes it jump to the other side of the number line for 0, and that makes that a positive 5. But what did we just see here? Because we just accept this as truth. Well, we just saw that this negative times this negative made it positive. So when I have two negatives, I end up with the opposite of a negative, and the result will always become positive. So when we're multiplying, if we have one negative, it makes it the opposite of a positive, makes the answer negative. And whenever we have two negatives, it's the opposite of a negative, which makes it positive. So just a couple ways of thinking about it. We also need to be able to handle numbers like these. Okay, so 4.56 times negative 10. Well, I already know that I have a positive times a negative, so I know that my answer will be negative. Put that down on your notes, but that shouldn't be something you have to memorize. That should make sense, okay? You need to be able to do 4.56 times 10 without a calculator. So write down 4.56 times 10. There are a couple ways of doing this. I could multiply everything by 0 first. 0 across everything just kind of zeroes out. But then, that doesn't really do anything, so I'm not going to write those down. But when I move to the second digit and I multiply everything by 1, because I'm on the second digit, all the values have to move over 1. So you basically can put a 0, or some people put an X or whatever, but you have to move over one place when I move on that second digit. So 1 times 6 is 6, 1 times 5 is 5, 1 times 4 is 4. And then one last thing to keep in mind is basically you have to look at how many decimals are there in this question. This answer is not 4,560. That would be crazy, right? If I got $4.56 times 10, I don't end up with 4,000. That decimal makes a big difference. So you look at this and go, there are two numbers past the decimal, not paste, past the decimal. This 5 and that 6. So I go down here and I move the decimal twice over. So my final answer should be 45.6. Don't forget, positive times a negative, negative 45.6. Once again, we need to know how to multiply fractions. So this is going to be something you need to know how to do. You're like, well, I don't see fractions. I see a whole number. You need to remember that is 16 over 1. Okay? So at this point, I'm going to go, before I even multiply these numbers, I'm going to see a negative times a negative, and I'm going to go to my answer and go, I know this answer is positive. The opposite of a negative is positive. Okay? Then I'm going to do like, I do this, I call this the 5th grade math. We're going to do this on the side. It's so funny. This is what scares us, but this is what, we need to be able to handle. There are a couple options with this. So far we've talked about how do you multiply a fraction straight across. If this is not the way you're going to do this, this is fine. I'll show another way. But we have 16 times 5. Some of you know that it's 80. You're not, and other people go, oh my gosh, that's such a great trick. How do you do that math in your head? They're not doing any magic tricks. They're just doing 6 times 5 is 30. 5 times 10 is 50, plus the 3 is 80. They just can do that in their heads. It's not a magic trick. It's not like they're doing some magic, math voodoo to get that number. They're just able to multiply this in their head. So some people are like, well, I can't do that. Awesome, then show the work. You're really doing the same thing. Just because you can't do it in your head doesn't mean you can't do the math. Show the work you need to show. So where were we at? On the top is 80. On the bottom, 1 times 32 is 32. Bad news is we're not done. 80 and 32 must be reduced. So I'm going to divide the top and bottom. I would see something bigger, but if you're not sure, you go, well, at least they're both even. Let's cut them in half. Half of 80 is 40. Half of 32, that might be a little trickier. 32 divided by 2, 1, 6. We have 16. Still not done. Unfortunately, both of those are still even numbers, which means they must still be divided by 2. Half of 40 is 20. Half of 16 is 8. Still not done, because 20 and 8 are still divisible by 2. This is where I was saying, maybe if you had try to divide it by 4 or something bigger, that would have been awesome. I think 8 was the biggest one, but that's okay. Half of 20 is 10. Half of 8 is 4. Still not done, because 10 and 4 are still even. So that we end up with 5 over 2. By the way, this is the way that they're wanting you to put this answer. It's 5 over 2. I've seen several of you doing 5 divided by 2 and making that 2 and 1/2. I'm fine with this, but the book, the homework is going to be wanting you to put it in as a fraction. Okay, I will accept either on the test. They are the same answer. Okay, so this was one way. This is not actually the way I would have done this question. Here's what I would have done. I know that I'm just multiplying these across. 16 times 5, 1 times 32. But when I make it one big fraction with the top times the top and the bottom times the bottom, I can start reducing, really simplifying things here. For instance, I could take that 16 and 32 and divide them both by 2. If I divide the 16 by 2, it would become an 8. If I divide the 32 by 2, it would become a 16. And I go, now I got an 8 and a 16. Well, wait a second, I can see, I remember 8 goes into 16. So I now could divide them both by 8. If I divide 8 by 8, I get 1. If I divide 16 by 8, I get 2. So as long as you do top and bottom, you can actually kind of simplify and reduce it before you multiply it together. If you multiply it together first, you can still get to the answer. You just got to do all that simplifying at the end. If you can see to simplify at the beginning, all I'm left with on the top is 1 times 5 is 5, and 1 times 2 is 2. You got choices. Some of you, I just showed you that and you're like, I don't get it. Then don't do it that way. Some of you are like, that's exactly the way I do it. I always like to ask the question, right? Which way's right? Well, they're both getting us the same answer. They're both mathematically sound. Both are right. Which way's better? Well, that's completely up to you. If you like this, what I showed here, do it that way. If that is utter nonsense to you, then do it this way. Either way, it doesn't matter. You're still doing the same mathematics, getting the same answer. Do what gets it right. Do what helps you understand what you're doing. All right, let's keep going. What if I have more than one negative? Well, negative 2 times 4 times negative 1. Once again, I've got some choices here. I can multiply this from left to right. Negative 2 times 4, a negative times a positive is negative. 2 times 4 is 8. So now I have negative 8 times negative 1. A negative times a negative makes it positive. So I end up with positive 8 times 1 is 8. That's not the way I would do this. The way I would do this is I would see that there were two negatives in the whole question, and I know that a negative times a negative makes my result positive. And then I would just multiply the numbers across. 2 times 4 is 8. 8 times 1 is 8. You have choices. Same with this one. I can go left to right. 3 times 5, 15. Because there were two negatives, that 15 is positive. 15 times negative 2. A positive times a negative. I'm going to have a result that's negative. 15 times 2 is 30. You can bring it down and do it step by step. That's not the way I would do it. I would see from the beginning 1, 2, 3 negatives. Now I know that 2 negatives becomes positive. So 3 would mean a positive times a negative, that my result would be negative. If there are an even number of negatives, then the result will be positive. Because I can group them up in groups of 2, and every 2 make it positive. If there are an odd number of negatives, then when I group my 2's, there will be one left over that makes the result negative. Okay? And then what would I do again? Just multiply across. 3 times 5 is 15. 15 times 2 is 30. I just did that in my head. If you're like, I don't do 15 times 2 in my head. I don't care. Do this. It's the same exact thing I'm doing. I'm just doing it in my head. 5 times 2 is 10. 2 times 1 is 2, plus 1 is 3. Show the work you need to get it right. When we talk about reciprocals, reciprocals mean that you take a fraction and you flip it. Okay? We're going to show how they actually can do a lot of different things with reciprocals. I'll show you in a little bit. But if I take 1 over 3 and I flip it, most people will tell me 3 over 1. Now, I don't need that 3 over 1. That doesn't bother me, but 3 divided by 1 is really just 3, right? I would accept either of those. I'm pretty sure the homework would too, but reciprocal flips it, right? Notice that the beginning was positive, and the reciprocal was also positive. The sign didn't change. Reciprocal does not mean opposite. Reciprocal means flip it. So if it's positive, my result is positive. What if it's negative? Well, I can still flip it. You're like, how the heck do I flip negative 5? Make it a fraction. Negative 5 over, whenever it's a whole number, it's over 1. If I flip that, I get the 1 over negative 5. I wouldn't leave it like that. I would write that as negative 1/5, or we can have the negative kind of travel to the top, negative 1 over 5. Either of those I would accept. But notice what? The beginning was negative, reciprocal, the result was still negative. The sign doesn't change. What about 0? What happens if I flip 0? Well, what is 0? Well, it's a whole number, so 0 over 1. If I flip it, I get, what is 1 divided by 0? That is called undefined. That's a little advanced. I don't see that popping up, but the idea is you can still flip it. You cannot divide by 0. You cannot pull out groups of nothing. 0 divided by 1 is 0. 1 divided by 0, you can't pull out groups of nothing. We have that defined as undefined. Kind of funny. Here's the good news. The good news is multiplying and dividing are actually related to each other. That's why when we do PEMDAS, they are grouped together. All of the rules for multiplying are the same as all of the rules for dividing. So if you understand the rules for multiplying, you understand the rules for dividing. A negative times a negative. If there are 2 negatives, the result will be positive. If there is 1 negative, whether it's at the end or at the beginning, I don't know what that is. If we have 1 negative, the result will be negative. And if we have 0 negatives, you'd be surprised. I have people who are like, a positive divided by positive. I know there's a rule for that, and they just make it negative. That really makes me sad. Don't make these tricks. This should make sense. Okay? 1 negative leaves the result negative. 2, the opposite of a negative, they cancel each other out and make the result positive. Okay? So if I do 12 divided by 3, please don't put negative 4. You need to know from before, a 12 divided by 3, yes, is 4, but a positive divided by positive leaves it positive. This we've talked about before. I just read that as 12 divided by 3. You need to know those mean the same thing. This means the same thing as 12 divided by 3. Okay? Negative 1.7 divided by negative 7. Oh man, I thought those decimals were going to go away. Let's just deal with this at the beginning. A negative divided by a negative, the result will be positive, just like it was with multiplying. Can you do 1.47 and divided by 7 in your head? I can. It's not some great magic trick. All I'm doing is this in my head. 7 into 14 would be 2. 2 times 7 is 14. Bring down the 7. 7 into 7 goes one time. Gives us a result of 0 down there. So we have 2, 1. Take the decimal, bring it up, so that we have 0.21. Where was that at? Right here. So 0.21. Generally, and I keep meaning to bring this up, you do not need to put these little plus signs. I just like to kind of show you. If you do on like the test, I don't think it's going to mark you wrong, or I won't mark you wrong on that. I don't know what the homework would do. I don't think it would freak out too much, but I just like to make note right now that 2 positives makes it positive, 2 negatives makes it positive. The rules don't change. Sorry about that. Here we go. What about a fraction divided by a fraction? Oh my gosh, right? Let's all freak out. This is terrifying. Like, this was hard enough when we were just dividing regular numbers. Now we got decimals, now we got fractions. Yeah, this should be a skill you've seen before, okay? Now, 2 options. I know that this means divide. Okay? I know that this means negative 3/4 divided by 1/2. But what I'm going to do, rather than just show you the trick, because there is kind of a trick for this, I'm going to show you where the trick comes from. When we divide by a fraction, can we agree that this is terrifying, right? What could we multiply by to clear out 1/2? What could I multiply by? Well, this is 1 divided by 2. What if I multiplied by the reciprocal? The reciprocal, we just said, is where I take 1/2 and I flip it. What if I did 1/2 times 2 over 1? Well, that would give me 2 over 2. Those would cancel out and make that denominator just a 1. That would clear out that for us. It would make our lives much easier. Can I just do that? Just multiply 2 on the denominator? No. The idea is whatever I do to the bottom of a fraction, we must also do to the top. Basically, we're multiplying by a very complicated looking, I like to call it a very complicated looking 1. Because I'm doing it to the top and the bottom, I'm basically multiplying this fraction by a very complicated looking 1. Okay? So what does this become on the top? Negative 3 times 2 is negative 6. 4 over 1, or 4 times 1 is 4. I don't need this anymore, because anything divided by 1 is just itself. So I can just reduce the negative 6/4 by 2 and get negative 3/2. Here's the good news. This is not the way I want you to do this. This is just the reasoning for what we're going to do. See, I don't like having a fraction in the denominator. It is not easy to divide by fractions. It's complicated, it's messy, so we didn't. We said there's a better way. Rather than divide by that fraction, I can multiply the top and the bottom by the reciprocal, and the bottom just goes away, and the top I multiply and I got my answer. So I can do the same thing here. How do I divide by a fraction? We don't. It's more complicated than I want it to be. What do we do? Multiply by the reciprocal. So I can take this negative 3/4 and go, I don't want to divide it. It's complicated. Change that division to multiplication. Can I do that? Yeah. And I multiply the top and bottom, or I multiply this negative 3/4 by the reciprocal. What is it really doing? Making that bottom go away, and then I just multiply the top to get negative 6 over 4, or negative 3/2. So you do need to know how to do that. Whenever I have a fraction divided by a fraction, we don't divide by that fraction. We multiply by the reciprocal. The first one stays the same. We change it from division to multiplication, and then we change the 1/2 by making it the reciprocal 2 over 1. This is just the reasoning. There's like a couple homework questions where they're kind of messy vocabulary, and they're like, how would you divide something by something? And you have to say, take the first number and multiply it by the reciprocal of the second. It's kind of complicated. I wouldn't ask you that on the test, but I don't mind leaving something like that in the homework. Let's keep going. Negative a over b is the same thing as a over negative b. If I have one negative, whether it's on the top or the bottom, the result is negative. Negative a over negative b. If I have two negatives and I divide them, the result will be always positive. Okay, we're almost done. Let's deal with some word questions. Okay, well, let me look at this real quick. If I said, I'll just do a nice number. Let's do negative 6 divided by 2. And that should be the same thing as 6 divided by negative 2. In all of these situations, 6 divided by 2 is 3. And in all of these situations, the negative's at the beginning, so I just get a negative. I get the same result either way, whether the negative's on the top or the bottom. If I have negative 6 over negative 2, if they're both negative, I'm arguing that's the same thing as if they were both positives. The two negatives cancel out and make my result positive. So in both of these situations, if I have two positives or two negatives, the result is positive 3. Kind of deep thoughts, but let's go ahead and keep going. Some word questions. The quotient of 14 and the sum of negative 9 and 2. Whoa! The quotient. What does quotient mean? We need to remember these words. This is still building from that first section. We had sum was addition. Difference was subtraction. Product was multiply. Quotient was division. We are going to be dividing 14, quotient of 14, and, or divided by, the sum. What does sum mean? We are taking these two and we are grouping them by addition. So we are dividing 14 and, or by, the sum of negative 9 and 2. This is the quotient of 14 and the sum of negative 9 and 2. You could write this as 14 divided by negative 9 plus 2. That would mean the same thing. Just be careful. I think the top one actually makes a little more sense, kind of with the grouping. What do we end up with? 14 divided by, what's negative 9 plus 2? More negatives makes it negative 7. What is 14 divided by negative 7? 14 divided by 7 is 2. Positive divided by a negative is negative. This would give me the same result. I would have 14 divided by negative 7, which would still give us negative 2. Okay? The product of, let's see what this one is. The product of 5 and negative 6 divided by the difference of negative 7 and 8. I will probably have some things like this on the test, but not to this difficulty. The homework's going to have some harder ones that I'll have on the test. So what does product mean? I am taking 5 and negative 6 and I am multiplying. So I'm going to multiply 5 and negative 6 divided by, well, that's easy. Do I want to do this one? I think it's easier to do divided by. The difference of, difference means what? We got to know that means to subtract. So negative 7 and 8 means negative 7 minus 8. This mixes our rules. We need to remember our rules. 5 times negative 6, a positive times a negative is negative. 5 times 6 is 30. Negative 7 minus 8. I can do that and get negative 15. I encouraged you, if you're not seeing that, to remember that this means the same thing as negative 7 change plus negative 8. So we get negative 15. I also know that a negative divided by a negative, my result will be positive. Now I could divide. I know 15 goes into 30 twice. I get 2 and I'm done. If you don't see that, you could try to reduce it by dividing the top and the bottom by what they have in common. That would make that a 6 over a 3. If I divide the 6 and the 3 by 3, I would get 2 over 1. That's fine. Really, we should write our answer as 2. Okay? So, take it out, write it out with the expressions, simplify it. Still, these are our word questions for now. This is an equation though. See, this is actually going to be different. We're going to take the words 3 times a number, 3 times, but a number we don't know, right? That basically stands for a variable. Generally, whatever you need, just go ahead and pick a sign. And so we're going to call that an x at this time. Is means equals negative 18. So now when I do this, we actually can solve this. 3 times what is negative 18? Some of you I saw in the last quiz knew how to solve this multiplication by division. That's great. Okay. If you divide both sides by the 3, you get that x equals negative 6. If you're not there yet, then what you would do is you would say 3 times what makes 18 is a 6. Positive times what makes it negative? It has to be negative. You can do this logically, or you can do this algebraically at this point. Really, out of the two, I'd prefer algebraically, just because that's going to help us in the long run. But you should be able to get negative 6. The quotient of, we are dividing, okay? 24, quotient means divide, divided by a number. What do we put for a number? X. Is, once again, means equals negative 2. This is not one that I actually want to do algebraically. I could multiply both sides by x and then divide. You're going to create several steps. This is one where it's actually, I think, easier to do this logically. 24 divided by what would give me 2? What goes into 24 2 times? Positive divided by what would make it negative? Well, if the top is positive, if this answer is negative, that 12 needs to be negative. You can solve this logically. If you did it the other way, you'd have to multiply both sides by x, divide by the negative 2, you'll get the same answer. Different ways of doing the same thing. These might be tricky. Like I said, we are going to be going into the algebra, and so that's really not in this section. They're wanting you to think about these logically. If it's easier for you to solve some of them algebraically, do it. If it's easier for you to solve them logically at this point, do it.